go again. Feel like I've done a million of these. Oh, I probably have. Hey, by the way, I haven't heard any comments about this slick new hairstyle I got. No shave. So if you've been watching my old ones. By the way, if you hear my dog, he's over in the crate for the next second because just keeping him over there. He's sleeping. So hopefully he'll wake up soon. Not wake up soon. Anyway, this is June 2012. If you are here to copy down exactly what I've written down here and you came here to watch your trained monkey, wrong place, wrong time. All right? Go do your own work. We are going to do June, what are we on? June 2012, 1 through 14. Let's get going. Let's see what we can get done for today. All right, so if you notice, these are conjugates. We've talked about conjugates before. Conjugates. That's not conjugate, that's conjugates. What they are is the exact same set of parentheses, except for we don't have a middle term. So notice, and this is kind of nice, they didn't give us any middle terms. So all we got to do is take the product of these. We're going to multiply. 2/5 times 2/5 is 4/25. These are out. And it's 4/25. X times x is x squared. I am finished. There it is. Just to make sure, 3/4 times 3/4 is negative 9/16. Done. Domain. Domain are the x values, so we don't need the y values. Domain are the x values. How far to the left did we go? -1. How far to the right did we go? I'm going to guess that's 7. 1, 2, 3, 4, 5, 6. I lied like a dog, and I should have just checked the answers. They had 6 there. Choice 1. Holy mackerel, this is an easy exam so far. I hope the whole thing is going to be this easy. It never is, kids. All right, so we're going to solve this in the interval. So we're going to solve. I'm going to move the 1 over. So I get 2 cosine theta equals 1. Divide by 2. So I get cosine equals 1/2. Now you can either use your brain and know that cosine equals 1/2 at 60 degrees. But I know a lot of you want to make sure and triple check. So if you're looking for an angle, inverse trig. So we're going to do inverse cosine of 0.5. We're going to take the inverse cosine of 0.5, 60 degrees. There it is. We're all done. Wait a second now. We've got to think. Cosine is positive in the first quadrant and in the fourth quadrant. So we need 60 and 360. By the way, just in case you're wondering, all students take calculus. All of them are positive here. Sine and cosecant, tangent and cotangent, cosine and secant are positive. Let's move on. We're looking for perfect cubes. 64 is a perfect cube. If you don't know your perfect cubes, you should. 1, 8, 27, 64, 125, and the next one is 216, but nobody ever asked that. These are the ones you should have memorized, and in fact, it's really just these. Now, a to the 16th, I can write that as a to the 15th times a. Now, why a to the 15th? Because it's a cube, I'm looking for multiples of 3, and 15 is a multiple of 3. So, when I bring out my other pen, because I want to make sure I fancy, get some Hilton colors going, the square root, or the cube root of 64 is 4, and the cube root of a to the 15th is a to the 5th. So I'm looking for a to the 5th cube root of a. See, this stays underneath. Done. Check my answers, by the way. There we go. All right, so now I'm looking for, let's see, we add 2, add 2, add 2, add 2. So I'm looking for, they give us the answer. So I just got to figure out which one gives me. So which one? It starts at 5 and ends at 43. So, well, I'm thinking this one doesn't make any sense because it's got a 20 on it. Man, that doesn't mean this one's got a 23 and a 24 and 20. This is the only one that makes sense. But this one would add 5, and then it would go to 6, and then it would go to 7, then it would go to 8. We need to skip count. We need to go by 2s. So this one goes by 2s. This one goes by 3s, so that doesn't make any sense to me. So it's got to be one of these two. So what I'm going to do is I'm going to plug in a 4. 2 times 4 is 8. 8 minus 3 is 5. Perfect. 2 times 5 is 10. 10 minus 3 is 7. Perfect. 2 times 6 is 12. 12 minus 3 is 9. That one works so far. Let's try this one. Put in a 1. 1 times 2 is 2. 2 plus 3 is 5. 2 times 1 is 2 times 2 is 4 plus that's a 7. So, and then it would be 9. So this one's working too. So since we checked those, we have to check the end. We checked the beginnings, now let's check the ends. 2 times 24 is 48. 48 minus 3 is 45. Ooh, that one is a 45. Let's see about this one. 2 times 20 is 40. 40 plus 3, 43. There's my answer right there. Moving. We're moving. We're flying. We're already almost halfway done with this. This is amazing. Amazing stuff. Awesome. Awesome stuff. Awesome. It's the craziest stuff. Awesomest ever. Holy crap. I just went to 200%. That's crazy. Crazy. Oh, 125. I'm trying to get to 150. You can tell I'm a little spastic. All right. So let's get back to red. Negative 50 degrees. Now, a normal angle in standard position will start here and go in this direction. That would be the positive direction. But if it's negative, we're coming back. So we're not looking for any. This isn't in standard position. It's got to start on the x-axis. This is not in standard position. It's got to start at the x-axis. These two are. This one going this way is in the positive direction. This one going this way is in the negative direction. Ka-chang! There's our answer. Moving on. Every time you guys get to these problems, I'm going to tell you what happens. Ooh, logarithms. Ooh, logarithms! Got a little nervous wreck. Okay. Whoa, I'm going to start my pen. All right, so logarithms are scary, scary, scary stuff. So what we want to do is we've got log base b of x, and we want to turn this side into a log base b. So, first thing I'm going to return is all of the exponents. I'm going to go through and return all the exponents. So that 3 goes to p cubed. This 2 goes to t squared. And this 1/2 goes to r. Now, I have to remember that r to the 1/2 really means the square root of r. I hope you guys have that memorized. So I'm looking for things with a square root of r, a t squared, and a p cubed. P cubed, t, but wait, this is a t squared under, but the t's on, the only thing that should be under the radical is the r. Wait, I got a t squared, I got a p cubed, and ooh, this is a possibility because there's r to the 1/2. P cubed, t squared, a square root of r, p cubed, t squared, square root of r. So one of these 3 is right. Got rid of this one because it's got that craziness. Now, this subtraction, when I condense those, they go to division. So what I should be finding is the t squared and the square root of r on the bottom and the p cubed on top. Now, why is this times? Well, because these are being added. And because they're being added, they both go to the bottom. They're being added. So my answer is this one, choice 4. Moving on, kids. Sum of the roots. The sum of the roots is equal to negative b over a. Now, if we make a 1, then that's what, well, hold on a second. So what we want to do is negative b, it's negative b over a. So what we'll do is we'll say, okay, the sum of the roots is 9/4. So I'll say, okay, 9/4 is equal to negative b over, now look at all the a values. I can't make a1 because they made a4. So I already know that a is 4. Well, if a is 4, then what should b be? Well, negative b is 9. Therefore, b should be equal to negative 9. Boom, done. Can't be these two. And the product rule is c over a, which they've given us to be 3/4. Well, a is already 4. That means c has to be 3. There's our answers, kids. Yeehaw! That done been a good I don't even know what I'm saying, man. Seriously. It's getting close to lunchtime. It's like my 4th or 5th time doing this today. Absolute values in your brain, right here. Thing that keeps the hair growing. Crap. And the ears from slamming together. That's all mine's doing now anymore. Gave up on the hair. Told me to go someplace. The thing you got to remember with absolute values is you get the joy of solving 2 questions. This was math teachers' ability to say, look, how can we get kids to solve more than 1 equation? I got it. Let's create this thing called absolute value. Then you have to solve 2 equations. I can say, oh, kids, you only have 10 homework questions when you really have 20. That's evil. Absolute value. You have to remember that you have to solve two equations. The original, there it is, and the modified version of this problem. First things first, you got to get the absolute value bar by itself. It is. Now notice I did not change the left side. Leave the left side alone. That's my left hand. This is the left side for you guys because you're looking at me backwards and I'm backwards on the video. Never mind, shut up. So we only mess with the right side and the inequality, so it becomes less than -1. Now, in order to get rid of this nasty 3, I'm going to multiply both sides by 3. So now I've got, these 3's cancel. I get 4x minus 5 greater than 3. 4x greater than 8. X greater than 2. Not greater than 2, not greater than 2. Now I'm going to come over here, multiply both sides by 3. I get 4x minus 5 less than -3. Bring the 5 over, I get 4x less than +2. Divide by 4, I get x is less than 1/2. That's less than a -1/2. There it is, less than 1/2. My answer. Meine Antwort. Das war meine Antwort. Ich liebe, wenn ich die richtige Antwort habe. I love it when I have the right answer. Okay, kids, here we go. I know you want me to speak in German the whole time because then you truly wouldn't understand anything. You're sitting here saying to yourself, all right, math's already hard enough, Krause. Now you're going to start talking in German? Well, du musst etwas lernen. You got to learn something. Might as well teach you something. Here's your first lesson. I'll teach you the word for hello in German. It's very easy. Hallo. Goodbye. Goodbye. No, I'm just kidding. It's Auf Wiedersehen. Auf Wiedersehen. Unless you're from Schwäbisch. They say tschüss. Tschüss. Yeah, they're weird down there. That's where my wife's from. All right, let's rewrite this. I'm going to rewrite it like this. X to the -1, y to the 4th, 3x to the -5, y to the -1. Notice how I separated the 3 from the negative, from this 5. They have nothing to do with each other. Now, negative exponents. I've said this a million times. I keep saying it. Every time you watch a video of mine, you're going to see this. X to the -1 is 1 over x to the +1. X to the -2 is 1 over x to the +2. X to the -3 is 1 over x to the +3. Should I happen to have 1 over y to the -2? That comes to the top, and that's equal to y squared over 1, but I don't care. What if I had 1 over z to the -5? Well, that would come to the top and become positive. So, as long as they're all multiplication, I can do this. So what we're going to do is we're going to take this one, we're going to slide this down. We're going to take this one and slide this up. We're going to take this one and slide this up. So what I have then is x to the 5th on top, y to the 4th on top, y to the 1st on top, and on the bottom I have 3x. How many have 3x on the bottom? Not too many. So this is really y to the 5. Now here's what I got to remember to do. Briscoe, I'll be right with you, buddy. I'm going to get rid of this x, and I'm going to get rid of one of these x's. That leaves me x to the 4th. So I have x to the 4th, y to the 5th on top. There it is, all over 3. All right, kids, we got like 4 problems left, right? Ka-ching, ka-ching, ka-ching. What the heck? I hate that. Hate it. Ich hasse das. I think that means I hate that. So, what do we have here? Which graph represents this? Which one is the log of base 2 of x? Bust out the calculator, crowd. Yeah, I'm going to bust out my calculator. Log base 2 of x. Now, before I hit that, I'm going to tell you right now, log equations go like this. So the answer is, whoa. It didn't have any shifts up or down. See, normally I'd say this one, but that would be a plus. This is the normal log curve right here. So that's got to be the answer. 1, let's hit it, let's hit it, let's go, let's go, let's hit enter. Bam, there it is. Done. Choice 1. Choice 1, this is my right answer. Ka-ching, 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 right? I know, you're thinking I'm crazy. So a circle is drawn to represent a pizza. Pizza, oh my God, pizza. It's only 10:15, can't be hungry. The diameter is 12. D equals 12. The circle is cut into 8 congruent pieces. Let me cut this thing into 8 congruent pieces. Ding 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 ding. 8 pieces. What is the length of the outer edge of one piece? Oh, I know the answer. Who cares? Nobody cares. I don't care. I really don't. But you do, because you have to solve this. Now, let's see. I remember that when we're talking about the outer curve, I'm going to use this formula, S equals theta r, where theta must be in radians. And this is my radius. See, r. Radius, radians, r squared almost, kind of, but not really, not even close, but it's radians. So I know my radius is 6. I just have to figure out what in the H-E double hockey sticks this is. So I can do a couple things. I can say, okay, I'm going to take 360 degrees, and I'm going to divide it by 8. This is the hard way to do this. And then I go into my calculator, I go, oh, 360 divided by 8 equals. And then I'm going to actually do it, 360 divided by 8, and I'll find out we're at 45 degrees. So each of these is 45 degrees. Then I'll take each of those and convert it. So I'll take 45, and to convert it to radians, I multiply by pi over 180. Let's see, and if I do that, I get 45 pi over 180, and then I reduce that, and I get pi over 4. Can I show you an easier way to do this problem? You're thinking to yourself, holy crap, why not? Why didn't you show us the easy way to begin with, you stupid son of a so and such and such? How many degrees is that? I just drew it in fancy color. How many degrees is that? That's pi. It's 180 degrees, or it's pi, right? And I only want this piece. Well, that's 1, 2, 3, 4 pieces make up pi. I only want one of them. It's pi over 4. So pi over 4 goes here. So what I end up with is 6 pi over 4, which when I multiply these two, which is 3 pi over 2. Ka-chang! Woo! I know, I've lost my freaking mind. I knew it. I lost my mind. I'm going to show you 2 days to do this problem. I'm going to show you the cheating way. Why can't I do this? I'm going to show you the cheating way, and then I'm going to show you the cool way. So first we're going to do it now. First we're going to do it the math way. In order to solve these, you have to square this. Square this, and you have to square this. So on this side, I get 5x squared plus 29. And on this side, I get x squared plus 9, correct? Seriously? Go back to algebra. No. God, that makes me want to get sick every time I see a kid do that. You are so lazy when you do things like that. I call you lazy. I don't care. Your mom's probably in the background. Your dad's probably in the background. Is that teacher calling you lazy? Why are you watching that guy? He's a negative Nelly. Stop doing that. You don't just go, oh, look, x squared, 3 squared. It doesn't work that way. You have to double distribute. Please, kids, don't embarrass your teacher by doing this. We sit in a classroom. All of us do. Any school. It doesn't matter what school you go to. We sit in one room and we grade papers. And you know what happens when a kid does that? Oh, hey, Mr. Krause. You got a stupid kid. You must not have taught him well because he just did x squared plus 9. Oh, my God, did that kid do that? I'm so embarrassed. And then I haunt them for the rest of their time in high school. You have to double distribute. X squared, this turns out to x squared plus 6x plus 9. Okay, so I want to move all this stuff over, so I get 0 equals x squared plus x minus 20. Factor it, x plus 5, x minus 4, and I get 2 answers, x equals negative 5 and x equals positive 4. And then I get an answer, and I come over here, and I say, oh, there it is, x equals negative 5 and positive 4. Oh my God, algebra 2 is so easy. I got it, I can factor. And you get the wrong answer! Come on! You know your teacher told you have to check these. You know it! Oh, I know, I'm a little animated today. I apologize. You have to check your answers, children. Check them. Check them. So, first answer I'm going to check is, what did we get? Negative 5. Negative 5 stow x. Oh, and then enter. And then I'm going to say, oh, let's take the square root of 5x plus 29. And what do I get? What do I get? 2. And then I'm going to take x and add 3. Oh, negative 2. Not quite the same, is it? So I guess negative 5 is not going to work. Looks like positive 4 should, though. So let's do 4 stow x. Let's just make sure. Maybe we did both of them wrong. Maybe I don't even know what I'm talking about. Maybe I got the wrong answers. Why not check your answers? You got all day. 7. Yes! Check your answers, kids. That's my forewarning to you. Last problem, and then I am done. I am out of here. I am gone. Factored completely. Are you kidding me? How easy, Krause, man. What the? All right, let's take a look at these two. And then we'll take a look at these two. And then we'll be done. This one I'm going to take out an x squared, and I'm left with x plus 3. This one I'm going to take out a minus, because that's the minus. And I'm going to take out a 4, and I'm left with x plus 3, because negative 4 times positive 3 is negative 12. So then I end up with these two, make up my first one, which is x squared plus minus 4. And this one gives me x plus 3. I only use one of those. So this might be your answer. Everybody wants to pick that, except this is the difference of perfect squares. X plus 2 and x minus 2. So this, my friends, is the correct answer. Shabam! Part 1's done. Keep looking for part 2. Don't cheat. Keep working hard. Summer's coming. Holy crap, I can't wait to be sunbathing in the... No, I'm just kidding. I don't sunbathe. I'm going to be out there working on the yard. Probably doing Common Core Trig for next year. Oh, yay! Oh. Teaching's a lot of fun, though. I do get the summer off. I get to do whatever I want. So, I don't know what I'm going to do. You, if you get 100, email me. Let me know. Put you on my wall of fame. Tell me your school. Tell me your name. If you like, hit subscribe. Tell your friends to subscribe. I'm going to be doing all of these. Don't cheat. Work your butts off, kids. School's almost over. Summer's coming. Bye.